Okay. So this chapter of radioactivity, there are certain things which we will be doing like a previous knowledge, something that you already know. So what topics are covered in this exercise? First is the structure of atom and nucleus. Then we will be talking about what is radioactivity. We will be talking about then the uses of radioisotopes, and then source of harmful radiation. Also, what we will be doing, and then safety precautions while using nuclear energy and background radiation. So these are the topics that are there in the first exercise. Now moving to the first part, that is structure of atom and nucleus. So in this, when you talk about an atom, you have studied in your lower classes that an atom composed of nucleus and there are electrons which are going around the nucleus. So this is how an atom looks like. Okay. So these things are electrons and this is the nucleus. Now, when we study the nucleus, so inside the nucleus, there are protons, okay, and there are neutrons. Now, the number of protons is equal to the number of electrons. And that is the reason why the atom is electrically neutral, because one electron, now this is not from this chapter, but we have studied earlier, that one electron has a charge of negative 1.6 into 10 to the power minus 19 coulombs, and the charge on a proton is plus 1.6 into 10 to the power minus 19 coulomb. So that is the charge on one proton. And because the number of protons, number of electrons are same, the net charge on an atom is 0, and an atom is said to be electrically neutral. Okay, so then you have studied about the letters, like say for example, an element is denoted by A and Z, where what does A stand for? A stand for atomic mass number and Z stand for atomic number. Okay, now what is Z? Z is the total number of protons. And what is A? A stands for the total number of protons plus the neutrons. That means A stands for the number of nucleons. Okay, let's take an example. So if you have an atom like uranium, which is 235 and 92, that means that the number of protons are 92 and number of neutrons will be 235 minus 92, that will be 143. So this is also you have studied in your lower class chemistry. Any questions so far? Okay. The next thing which is there in this chapter, it's unlikely to be asked in the board exam. Okay. However, you are expected to know this. So what is an isotope? So you need to know the meaning and you need to know at least two examples. So isotopes are same elements. Okay. So if you have a carbon isotope, there will be all will be carbon elements. That means the Z value is same, and the value of atomic number, atomic mass number will be different. So let me give you an example. Let me just clear this first. So example of isotope, I'll give you carbon isotope. Then you have carbon, there is carbon 13 as well, and carbon 14. Carbon 14 is radioactive, okay? So in this particular case, you see that all of them have 6 protons, but the number of nucleons, it varies. So therefore, these are called as isotopes. The next that we have is isobar. So in isobar, these will be different elements. So that means A value is different for them, but Z value is different, sorry, and A value is same. So these are isobars. So what are the examples of isobar? So you have carbon 14 and you have nitrogen. So you can see that for them, the value of Z is different. So you have 6 and 7, but value of A is 14 for them. So the number of nucleons are same in an isobar, okay? And then you have isotones. So in isotones, A minus Z is same. So there will be 2 or more elements which will have the same value of neutrons. Okay, so A minus Z gives us what? Neutrons. So that means in an isotope, you have same number of protons. In an isobar, you have same number of nucleons. That means proton plus neutrons. And in isotones, you have same number of neutrons. So for isotone, the example is sodium and magnesium. Okay, so in this, you have 23 minus 11, that is 12. And over here also 24 minus 12, that is 12. So that is isotones. Any questions? Okay, so the next we are going to move ahead with radioactivity. So the first, there are many questions that come to your mind. I have listed down some of the questions over here, and I will answer those questions. If you have any more questions, please do ask. So which substances are called as radioactive substances? So the answer to this question is heavy elements. Heavy elements means what? Substances which have atomic mass number more than 180 are called as radioactive substance. Then the question arises is, when do you say some elements are radioactive? Like, what do you mean by that? So when you say that, say uranium is radioactive or radon is radioactive, so radium is radioactive, sorry. So when you say that these elements are radioactive, what do you actually mean by that? So the answer to this is they emit certain radiations. So when these substances are there, these substances give out certain radiations, and that's the reason why that name radioactive. Now, scientists have studied these radiations and they have been able to categorize that there are only 3 types of radiations that they emit, and they have been labeled as alpha, beta, and gamma. Okay, so these are Greek letters A, B, C. So alpha, beta, gamma is the name given to these radiations. Okay, so what have we discussed? The substances which are heavy element are radioactive. Why are they called radioactive? Because they emit these radiations. Okay, we will be studying further that what are these radiation actually meaning. So why do these elements emit these radiation? What is the purpose of giving out these radiations? So the answer to that question is to attain stability. That means they become stable or they attain the electronic configuration of lead. Now over here, the misconception generally students have, or not a misconception, is when you hear the word stable, you are only talking about the duplet state or the octet state. That is when the element lose electrons or they gain electrons or they share electrons. So students, here we are not talking about electrons. Okay, because we are talking about the nucleus, what happens inside the nucleus. So when I say these radiations, so I'm saying that there are these electrons that are orbiting, but all these radiations are given out from the nucleus. Okay, so it is a nuclear thing. So A, alpha, beta, gamma are given out by the nucleus. So the heavy element, which is more than 180, are trying to become lead or trying to become stable. Okay, any questions you have?
Yes, sir. So
Yeah.
basically, like if the electrons are present inside the sorry. So basically, inside the nucleus, the neutrons and protons are the ones that are emitting these radiations.
Yes, yeah. So the nucleus that is
Then
yeah,
no, no, yes, sir. Go ahead, sir.
yeah. So the nucleus that is there, that is giving out alpha, beta, gamma radiation. So when I say radioactivity, I'm talking about alpha, beta, gamma, and these radiations are given out by the nucleus. So when we are talking about stability, we are not talking about exchange of electrons. We are not talking about give and take of electrons. Okay, this will be much clearer in this chapter. What do you mean by stable? We will also be discussing alpha means what, beta means what, gamma means what. Okay, fine. You ask what question do you have still?
So basically, is there like a specific type for like instance like protons have to give out the like emit only alpha and
No,
neutrons
no,
only give out gamma? Is it like that?
no, 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 no. So now after this, we will study that alpha means what, beta means what. So that time it will be clear to you. Okay, so right now you just understand that all of these are given out by the nucleus. Okay. And why
So
do they?
what?
Yeah. Yes, go ahead. Ask.
So what kind of radiation? So what do you mean by radiation?
Yeah, anything that is emitted, we say that it has been radiated. Like there is a hot cup of tea, it is giving out radiation. That is infrared radiation. Okay, so when you have a Wi-Fi router, it is giving out radiation. That means it is giving out microwaves. So similarly, the nucleus of a radioactive substance like uranium is emitting these particles. Then we say that it is emitting radiations. Okay. Any other questions? Fine. So then, why are these substances unstable? Okay, so we have seen that what are these substances? Uh, what do they do? They emit radiation. Why do they emit radiation? Because they want to become stable. So we will now see if why are they unstable? Okay, or what makes them unstable? So the answer to that question is the neutron to proton ratio has to be greater than 1.5. So the meaning is that the the neutron to proton number has to be greater than 1.5. Okay, so if for substances who have that higher number are radioactive, okay, so substances with neutron upon proton number more than 1.5 are radioactive. Let me give you an example. So in uranium, which is 235 and 92, there are 143 neutrons and there are 92 protons. So when you do the division, you get 1.55, which is more than 1.5. And this is the reason why uranium is unstable. So uranium has far too many neutrons than the number of protons it has. So that makes it unstable. And you will observe the same thing for in all the radioactive substances. Okay. Do you have any questions?
So, but basically in a ratio, there is not like a specific unit. Then how do you actually consider 1.5543 to be actually greater than it? Because 1.5 has a unit while 1.5 doesn't actually have one.
So yeah, this is a number. This is also a number. So basically, in a stable nucleus, if you have, say, 3 protons, then ideally you should have 3 neutrons because this space is pretty small. It is of the order of 10 to the power minus 15 meters. It's very small. So for maintaining stability, it is the number of protons, the number of neutrons need to be nearly equal. But over here, what is happening is the number of neutrons are far more than the number of protons. And that leads to instability. Okay, that's the problem. And of course, the scientists have observed this number because in reality, you take a substance, you check whether they are emitting these radiations, so you know that will be a radioactive substance. And then they have studied the properties of those. Okay, you may have heard about the name of Madame Curie. So she was the one and her husband, they studied radioactivity for the first time. Okay. Any questions?
But what if it's like 1.4 then?
Yeah. So it will not be radioactive. So whenever it is greater than 1.5, it will be radioactive. And that's what I said. They are attaining stability. That means they are bringing down this number to less than 1.5. That's their effort. And to do that, they are emitting these alpha, beta, gamma radiations. Okay. Any
To do
questions?
what? To do
No, sir.
what?
No, sir.
To attain stability, they are trying to bring down this ratio to less than 1.5. Okay. Moving to the next, alpha, beta, gamma is emitted. So what is actually happening? Okay. So that is what we will see now. Alpha, beta, gamma radiation. So basically, uh, an alpha particle is emitted. There are 2 protons and 2 neutrons leave the nucleus. When a beta particle is emitted, there is an electron leaving the nucleus. And when a gamma particle is emitted, there is energy in the form of electromagnetic waves being emitted. We'll be studying this again little ahead in this chapter, but for now, I can just tell you that from the nucleus of an atom, okay, when an alpha particle is emitted, That means the nucleus is losing 2 protons and 2 neutrons. From the nucleus of an atom, when a beta particle is emitted, the nucleus is losing an electron. And from the nucleus of an atom, when gamma is emitted, that is nothing but excess energy, which is electromagnetic wave. Okay, any questions? Fine. Now, nuclear radiations are spontaneous radiations. The meaning of the word spontaneous means you cannot predict the emission. It is random. So the meaning is that when you have a radioactive nucleus, okay, you
Sir,
know
emission matlab?
it emit is giving out, like the sun emits light, so emitting, okay. So you know that the nucleus gives out alpha, beta, gamma radiation, but you cannot be sure that now it will give out alpha, now it will give out beta. You cannot predict that, okay. So neither it is in a random order, means like in a proper order. So that is the reason why it is said to be spontaneous. It is said to be random. Any questions on this?
No.
Okay.
So could you repeat why it's said to be random?
Random is something that you cannot predict.
No,
Okay.
I said could you repeat why it's said to be random?
Why? Because, yeah, why is random? Because it is random. That means you don't know or you cannot predict that alpha, beta, gamma, when will it be emitted? You cannot time it. You cannot say that, okay, now alpha will be given out. Okay. You cannot say that, okay, now beta has been given out, so now the next it will give out alpha. So there is no pattern in it, and there is no predictability in it. It's a random phenomena. Okay, you study in math probability. Uh, there is a random phenomena in that. When you toss a coin, you don't know whether it will be a head or a tail, but you know it will either be head or a tail. So similarly, we know it will be alpha, beta, gamma, but you don't know which one will be emitted when. Okay. Now, this is a question for you. Read it carefully. So if the radioactive substance undergoes a chemical chain, that means it forms compound. It undergoes physical chain, that means it is heated up, it is solidified, it is melted. Okay, it turns into a liquid. So what do you think? Will that affect the rate of radiation? Will it make the radioactive substance less radioactive,
Mm,
more radioactive? What do you think?
no, I don't
Sir,
think.
no,
It'll
not
remain the
that.
same.
Okay. So the answer is no. Now, why do you think it is no?
So because if there is actually any change in their chemical or physical appearance or anything, but
Hmm.
still the amount of energy that they would be having from the nucleus would be the same. So the same amount of radiations would actually be emitted by them.
Okay, so see, actually, the answer is when a substance undergoes chemical change, the things which are involved are electrons. Like a substance forms a compound, so it either takes electron, gives electron, shares electron. Whenever there is a physical change, it is basically the structure of atoms and molecules. Like you make it solid, they become closer, you liquefy, they go away. Now, there is no nucleus involved in this. Okay, nucleus is not involved in this, and that is the reason why radioactivity is not affected by that. Okay, and simply, instead of explaining the whole thing, which I did in your exam, if you write it, there will be no change because it is a nuclear phenomena. You will get marks. This is a answer that is accepted in the board. So the question is pretty long, and the answer is pretty short. There will be no change because it is a nuclear phenomenon. Okay, fine. Now we move to this important part, that is alpha, beta, gamma. When alpha is emitted, beta is emitted, gamma is emitted, what actually happens? So uh, you have a substance, and when that substance emits alpha, the atomic mass number reduces by 2, and atomic 4, and atomic number reduces by 2. And we write it like this. Okay, so what is this? This is a helium nuclei. Okay, you all know what is a helium atom looks like. So there are 2 protons, 2 neutrons, and 2 electrons. So this is a helium atom, okay? And if you remove this is a helium nuclei. And that is precisely what is alpha particle. It is a helium nuclei because it has 2 protons and 2 neutrons. So when you have 235 and 92, it turns into 231 and 90, and this is helium. Okay, so this is a reaction that you will have to write. There will be some questions based on that. Then beta, what happens in a beta? Okay, so first understand this very simple thing. You have a neutron, so neutron has no charge. A neutron turns into a proton, which is positive charge, and an electron. Okay, an electron which has a negative charge. So together, again, there is no charge. So therefore, what can I say? The charge is conserved. Okay, so this is a neutron inside the nucleus. That neutron turns into a proton and an electron. And this electron is emitted as beta from the nucleus. Okay, also, the mass of neutron is slightly more than mass of a proton. And you are aware that mass of an electron is negligible, okay, compared to the neutron and proton. So in that particular case, mass is also conserved. Okay, let me give you one example now. So uranium is 235 and 92. That means the number of protons are 92 and number of neutrons are 143. Now, when uranium gives out a beta particle, okay, so what does that do? As I said, a neutron is getting converted to proton. So the number of neutrons become 142 and number of protons become 93. So this is 93 and 140. This will continue to remain as 235. And I'm going to write over here electron, like a beta. Okay, any questions? So here you have AZ, it turns into a Y, A remains A, and this will be Z plus 1, and you have an electron. Any questions?
Can you explain this again?
Yeah. So when a beta particle is emitted, you are expected to remember this equation that your atomic number, okay, from Z becomes Z plus 1, A remains A, okay. Now why? Because a proton changes itself into a neutron and an electron, and this electron is given out from the nucleus. Okay. Also,
Sir,
let
how
me.
is that possible? Electron from a nucleus?
Yeah, that's what I'm saying. The electron is not inside the nucleus. Uh, sorry, a neutron is turning itself into a proton and an electron. So basically, a neutron is turning itself into a proton and an electron. Do you get that?
Yes, sir.
Okay. So what happens is, like, you have a neutron here. So say, for example, this neutron will turn into a proton and it will simultaneously also emit an electron. So that is beta emission. So for beta emission, what you need to remember is that a neutron changes itself into a proton plus an electron, and that electron is emitted from the nucleus. Okay.
Sir, so like as in a normal neutron, is it actually made up of a proton and an electron?
No. Now in that is also pretty interesting. It's a branch of physics called as nuclear physics. If you have ever heard about mesons, bosons, pions, so these nucleons are also made up of further subatomic particles. Okay, but that's beyond our scope, not even in 12th standard. What are the neutrons made up of? So let me write it again. So you have 235 uranium. It will remain as 235, and this will become 93, and one electron is given out. So that is a beta emission. Okay, do you understand that?
Yes, sir.
Now the last one is gamma. So in gamma emission, okay, this is what is there. So there is no change, only energy is given out. So the number of the mass number, the atomic number, that remains unchanged. So I have explained you the beta emission, alpha emission, and gamma emission. Do you have any questions?
Yes, so like in the gamma last one, you said that gamma is released as an energy.
Yeah.
So all the radiations are just like an energy out of the nucleus in a sense.
Yeah. So like every reaction, if you saw, even the alpha one, I wrote over here A Z, then I wrote A minus 4, Z minus 2, and I have written over here that 4, and I wrote a Q over there. Yeah. So this Q is also energy. And when I'm
Is it
saying,
basically is it a constant for all the emissions?
means the amount of energy will vary. Okay, because the energy depends on a few things, which again, it's beyond your scope. It depends on the frequency. But I'm just saying that whenever a nucleus, okay, say for example, a nucleus is going to give out a chunk of, so this is alpha particle, 2 proton, 2 neutron. Now, when an alpha particle is emitted, along with that, some energy is also given out. So that energy is gamma.
Sir,
Yeah.
sir, can you explain the scientific use and the industrial use for the radioactive?
Okay. Do you have any other questions?
No, sir.
Okay.